Hi, Stan.
Hey, Jin.
I'll introduce new host of this episode, Stan.
Hello, everyone. So, Jin, what are we going to be talking about today?
You've done last 3 episodes, I think, with the excellent way to secure OIC API with APIGateway. So could be another, method to make sure OIC API is secured by, mutual TLS. I think that's the new topic we're gonna discuss today.
That's awesome, Jin. I think this is going to be a really good session and really continue and build on our previous 2 videos that we've talked about API security. So let's get stuck into it.
Okay, let me share my screen first.
Here we go. Yep.
Okay, so this is gonna be the high-level diagram about what we're gonna discuss. So it's quite straightforward, just extension to our open authentication journey for OIC API with APIGateway. We just add one more protection, which is mutual TLS. So make sure client is verified, trusted, and we know each other. That's the thing. Then let them consume API safely. Why we need to use TLS? So that's a good question. And firstly, the X509 certificate will be the baseline of full activity. So that's the certificate will be encrypted and guarantee the communication is done by the verified both parties, so server and client. So as you can see, there's a bit of flow over there. So number 1, 2, 3. Those flows are we used to do without knowing. So when client hit the API gateway, then what happened is behind scene is client verified the host name of API gateway, yada, yada, yada. So all things done without telling us, but now we want to add one more protection layer about, okay, do we know this client A? Are we allowed this client A to hit the API gateway endpoint? So that kind of protection was added by 4.6. Okay, maybe another question is why we need to do this for Oracle integration. Can you tell me, Stan, why we need to do for Oracle integration?
Yeah, so Jin, we're using the API gateway here because today, at least OIC cannot natively handle inbound mutual TLS. We can do outbound from OIC directly, but if you want to do inbound into OIC, you need to front OIC with an API gateway.
Okay. So I think that's the one of the reason I want to show this for OIC API. And of course, I think we know the last episode by Stan about the open authentication, try to protect the API into deep level or method level. So that kind of authorization is not done by the mutual TLS, but the mutual TLS is, I think, is very strong way to protect API with, for example, the whitelist. Then we know the exact range of IP and we know the client certificate we distributed, then they will lock down actual client is allowed to use API gateway endpoint. So that's all about this. That is why we use the mutual TLS.
Yeah, very good, Jim. Nice.
Yeah. So this is kind of like the quick summary of what is done, how it is done. So luckily OCI released the certificate services, I think last year. So one surprising thing is it's free of charge. So no cost at all. Then the customer should be able to control all self-signed certificate from CA to server and client certificate. So this is all about that. So maybe the first sequence of the full activity, we can see over there, like the CA certificate can be generated from the OCI certificate service. So maybe in case of, I don't know, a lot of use case customer, in case of banking industry, for example, or finance, they have this use case about having client certificate to be used for mutual TLS. Then by doing that, a bit of cost, I think, incurred for like paying for CA certificate for server and client. So I think by using OCI service, it can be done without any additional cost. And then another good thing is everything is controlled by customer, and they should be able to plan, like the CA goes for next 10 years, and then server certificate goes for 5 years or 30 days, and intermediate certificate go for maybe 6 months for each department. That kind of structure, customers should be able to manage it. So the first step I mentioned, so the CA, the certificate authority can be created from certificate service, then that is provided into the API gateway level. And then by using that, API gateway can verify client certificate. So that's all about. Then one more level is when client certificate is generated, there is a attribute called common name or SAN. Okay, I'll show you later, but those attributes can be compared from the actual API gateway deployment level. So if one endpoint is protected by specific client, what you see over there, ABC, for example, then when B has not presented that like common name, okay, firstly, when the client B has not presented the client certificate, then it will be rejected, the 401. That is not room number, this is an error number 401. So we got a joke about talking about the room number 401 can't be found, but yeah, anyway. So 401 will be issued. Then client A, when the client certificate will be the matching SAN or common name, then of course it is welcome the room number 200. And another use case when, let's say we haven't put even the client name, but when certain client, old client with all certificate with the unmatching SAN, then it will be rejected by 401 again with the invalid SAN, I believe. So that kind of security is done in this kind of flow. So
yeah, so Jim, basically, we can control specific client access to different APIs via the certificate that we issue to them, right?
I remember doing all those like certificate generation by OpenSSL command is, I think, it's not easy, very long command, and a lot of time mistake could be happen about entering information. So I think OCI certificate service will wrap it very easy and nice way for whoever like issuing the certificate without knowledge of how to do it. Yeah. Okay, so the baseline of doing this mutual TLS requires, the firstly certificate, and then of course it's mainly self-signed certificate from OCI. I think for this whole story we are talking about is about self-signed certificate by customer itself, and then by doing that, I'm sure the custom host name is introduced, and by doing that, actual DNS record needs to be managed with public DNS registrar. But the OCI comes with, again, nice way to manage customers' own domain name record. So I'm going to introduce those two services to make this mutual TLS happen.
Yeah, so this is all about assigning a custom domain name or host name to your gateway, right, Jim?
Yeah. So you can see there's a domain name over there, oci.myeipes.com. So that domain name is already registered in somewhere in public DNS registrar. So that is, I think, rule number one. Of course, you have to have that domain name registered somewhere in publicly. Then starting point in OCI, we can extend this as a usual normal DNS management. So like put a record or CNAME is up to customer, and then it's all their hands. So if someone asks about cost, I think it's not free, but very minimal cost again. So I think everything in one UI and I think one environment is important for customer as well.
Yeah, so basically the DNS holds the custom domain name, which will forward to the IP address of the gateway that we create.
Yeah, so maybe I'll show you that first. So this is the how the DNS journey is showed from UI level. Let me just move this. Then if I go into actual domain name, it's very straightforward about the usual OCI console matrix, but we go to the record level. There we go. So
yeah,
this is going to be the actual IP address of API Gateway I'm going to use for demo after this, but this is how you can, so I assign API Gateway dot and domain name. So this is going to be the new custom host name of our API Gateway. And you can put anything as much as you can, but this is going to be our domain name for API Gateway. And then the certificate, let's go for certificate. So how nice it is. So if I go for CA part first, so I'm going to show you the actual structure hierarchy next, maybe a few slides later, but first point is the root certificate. It can be generated here. And when it is done, if I just create something, then it doesn't ask much. So let's say stand. It's a fictitious, root CA. So stand, then what we can do. So just two options, root or intermediate subordinate. So that's it. Then just common name.
Yeah.
Next. So I think this is all about, and revocation configuration can be generated in object store, but yeah, we're not gonna go that level, but this is how simple it is. Let's say if customer wants to add the usual OpenSSL command style information, then there we go. So all information can be added here, but so that's how the root CA can be created. Then tying to this root CA, the intermediate CA, subordinate CA, so this can be created in the same fashion. Then, so this is kind of hierarchy. We're going to have root CA and then subordinate CA, which is an intermediate CA. Then actual TLS server or clients are issued tied to the subordinate CA. So that kind of structure is all customers' hand, and everything can be done in here without like running actual command. So,
yeah. So and these certificates here will be the ones used to sign the client certificates that will generate later for mTLS, right?
Yep. So I've done already to just save time. So you see over there. Yeah. So I create the TLS server certificate called demo API cert and client cert 1 and 2, and I'm going to show you later. But for example, in case of the client certificate, this is issued by the subordinate CA, which called OCI API demo subordinate CA. And then there's a user information about expiry and certificate type, key algorithm. And important information, is over here. So this is the very, very important information about this client certificate. So the common name. So I just extend one more layer on top of the server, the custom host name we use. So APIGateway OCI myeaps.com. So I just add C1 as a first client. And of course, these ways, the pattern is using the domain name, and certificate is try to use the subject alternative name, which is send. So it can be added more than one record over there. So customer able to extend their certificate to multiple domain name. But in this demo, I just make the same as a common name. So you see same information over there. So what it means when client present client certificate to API Gateway, firstly, the CA is checked by the CA given to API Gateway whether this client certificate is signed by this subordinate CA. Then what happened in second level is, do they have matching common name or matching send? So that kind of protections are there. Make sure this certificate is genuine and valid. Of course, all the information you can see, the expiry, that will be checked as well. What we are doing here is we want to protect the API from Oracle integration. Then the first level of the first activity what has been done is the API gateway has a deployment for that API. So, but the thing we need to know is when we just do that API gateway deployment, usually out of box deployment provide the long name of the OCI API gateway hostname what you see over there.
Yeah.
So that is the out of box, and then we want something special. But okay, it's not only for something special. When the API endpoint is given to customer, and somehow we need to change the deployment, then of course that name is controlled by OCI level, so we have no control. That means it will be changed. So we don't want client tied to that, the long name of out of box, the host name of API gateway. That's why we want to introduce the custom host name. Then we can map like any of API gateway with same signature in the future. So maybe, in case of the disaster recovery or maybe high availability situation, then you can control that original the custom host name with API gateway. So by doing that, we're going to introduce the OCI key management, certificate service, and DNS management. And then eventually, of course, the mutual TLS will be introduced by the API request policy called mutual TLS. So any comments, Stan?
No, I was just gonna say, having a custom hostname at the gateway, I think, is the best practice. We had this conversation before, and you mentioned some of the reasons there. Whether it's DR or something else, but fundamentally, because your clients are tied to this host name, right? You don't want to enforce any changes on your clients. So having this, domain that you can control and you can take anywhere, right? You can implement this on the OCI API gateway. Tomorrow, you might decide to move to a different API gateway. And doing so, you won't need to change all your clients because your endpoints stay the same.
Yes, that's right.
Yeah, I think that definitely should be a best practice the customers follow, whether they use mTLS or not.
Yeah, that's true. Whether hope it doesn't need to be OCI, but we have all capability here make this happen, and then the best practice is done in minimal of effort from OCI level. That's what I think want to emphasize as well.
100%. Yeah.
Okay. Yeah, so we back to custom host name. So maybe I'll show you that's how it is done first. So I'm gonna show you two API gateway deployment. So first one, so same API, OIC API is deployed here. So first one is my API gateway deployed. So this is out of box deployment. So what you see for the endpoint, this is what I'm talking about. So long host name of API gateway. So
generated,
So what has been done behind the scene, if we just look at a little bit closer, then so this was given. So you see over there the certificate internally wildcard.oci.oci-customer.com that was assigned to this API gateway when the provision happened. So what I'm going to do, so this is another gateway with same, the deployment done already, but just want to add. So this was the server certificate I showed you before. So what we need to do, just point this certificate. And when we generate this server certificate, we already provide the server name, domain, like common name and send already. So that will be tied to the actual runtime. So the first step for giving custom host name to the API gateway endpoint is make sure the domain name is preserved and then make sure that domain name is reflected in the certificate. Yeah, of course, to make the server certificate happen, firstly, root CA and intermediate CA, all those things needs to be done firstly. Then from the certificate service level, the actual certificate can be browsed from the API gateway UI. So what needs to be done is just select actual TLS server certificate and save change. Yep. So by doing that, I can hit this API gateway with the new custom host name, not with this old one.
Yes.
Okay.
And that's because your DNS will point to that IP address that you have there.
Yeah.
Right?
So I just change it. So let me just show maybe the few things. So if I go to, so this is just Postman request. I'm going to show you. So the one was the default one. So let's say you see the long name. This is the one I've done. I haven't touched it, just leave it as out of box. So yeah, we can just call and then we got API gateway orange. But for the new one with custom host name, you see API gateway something. So I haven't done anything. I just copied the request. So if I send it, I'm sure it's gonna be the complaint about certificate. Yep, that's fair enough. So let's just feed the information. Okay, what I want to provide is the CA bundle, which is a root subordinate certificate, which I can get it from UI. Yep. So how did I get it from UI? Then view detail again, view content. Yeah, so I can grab the certificate bundle from here, which is a root and yeah, to certificate, root and subordinate. So that's what I provided here. Okay. So now if I shoot the request, we'll be okay. Here we go. So 200. The next topic will be what can be done for mutual TLS, and I'm going to show it from certificate level and then Postman again. So let's just recap certificate over there. So the demo API certificate is what we're going to use it. Okay. And nothing special. It is, yeah. So by default, when certificate is generated, it will give option whether server or client or server or client. And I think there's another one about the code signing. So, but over here, we're gonna stick with server or client. And this is just for server side. And I'm gonna choose the client for actual client. But anyway, so this is the actual custom host name we use and then assigning to send common name like this. Yep.
Yeah.
And again, this is signed by the subordinate CA.
Yep.
And then client, we have 2 certificates. So make sure the send validation is happening. I'm going to show it from demo, but yeah. So this is the client one. Yeah, nothing special. And the common name C1 and actual host name. So same to send. And if you go to the client 2, nothing special and just different. Yeah.
So I guess the main thing is that these client certs are signed by the CA that you've imported into the gateway. So the gateway knows.
That's right.
Custom. Yeah.
So any certificate signed with this subordinate CA and with this attribute, with this common name and send, so then that client is like authorized to call API. Otherwise, the room number 401 will be given. Yeah. Okay. So let me just So let's go for this echo API and then, okay, just revisit. So we enable demo API.
Yeah.
Certificate here.
Yep. So
Nothing special.
that's the server side. Yep.
And then deployment, then go to actual deployment and edit. So let's do, mutual TLS, enable. And then let me just go there, make sure I introduce the right one. Okay, let me just put the C2 over there.
Yeah. So this second step is optional, right? Even if you enable mTLS, basically that first step, what that will do is just verify that the client cert that the clients are calling with is one trust, because that's signed by the CA. But if you want to go one step further and actually make sure that different clients can call different API deployments, this is where you'd use this.
So it can be added like as much as it can. I'm sure there's a service limit, but more than one SAN or common name can be registered here. So for example, we can go for 1 and 2. That means the client with those SAN will be accepted. But let's try, okay, let's go for C1 and then
that's a good point. Yeah.
And then next, nothing special. So you see over there, this is an OIC API endpoint. We just go for echo get. Save change.
So so now we have the deployment configured to accept client 1, which via mTLS,
so what it means when we call this API endpoint without client certificate and without the right SAN or command name, the room number 401 will be given. So
the server will reject it.
So the previous one with a simple server was fine, but what if we just send another request? I'm sure we're gonna have 401. Okay, so let me just go to the log, execution log. Remember, it will tell invalid certificate. So okay, so let me show the log. And there we go. So we have just one request, and then
it tells you that you got the 401 because the certificate
because certificate is in, but we haven't presented any certificate, right? Now let's try to provide client certificate to Postman with the right common name and SAN, then see what happened. So then one thing I missed to explain previously about the gateway setting. So, okay, for the gateway, we're gonna use it as you see the JPA API gateway. Then I show that we're pointing the TLS server certificate from the certificate service. Then that will be bind to the actual API gateway endpoint. But at the same time, when client certificate is presented, it will be verified against the self-sign, the root CA and subordinate CA. So that needs to be provided. So it is provided here to this API gateway. So you see the root CA, sub CA. So that is provided to the API gateway. Okay. I'll go to the mount back and let's provide the client certificate. So CA is still there. And then, so the certificate is done in the PM format. So let's add the C1 CRT and the private key as RSA format as well, and C1 key. And then we just need to provide the host name, which indicate when Postman send request with that host name, then we'll use that client certificate and private key. So let's go there. Yeah, just grab the host name. Yep, and edit. So we're all good to go. So what it means when, again, the Postman sends to the API gateway with this request, then this setting will be applied for that domain name. Okay. So we haven't changed anything, just provided the client certificate settings. So let's see. Oh, okay, it was successful. If we go to the log, I mean the console Postman, yeah. So client certificate is provided here.
Yeah.
Okay, so there you go. The last 5 minutes, it was the successful one, and we had successful response. Okay, now let's try the same API request, but with different client certificate. I mean, different from the common name or send. What it means, the client certificate was issued. Okay, let me just go through over there. Yeah, so same client certificate, but what I showed you before. So client 1 was welcomed by API gateway endpoint. I mean the API deployment because of this attribute over there, send or common name. Yeah, subject alternative name. So I'm gonna use different client at this time. The Insomnia is a REST API client, but we'll use this client to certificate with this. Okay, so let me just bring up. Okay, so yeah, this is the same. Yeah, this is the Insomnia, and another kind of the REST API testing tool. So got the same endpoint and a little bit different message, like APIGateway, mTLS, Insomnia. Then I already provide various token. What I haven't provided is just the client to certificate, right? So let's add it here. Yeah, client certificate, new one, and same thing, CRT and key. So okay, maybe it's good to share about how you can get the private key information, because if you look at actual certificate information, we can't see anything. So this is like client certificate I was playing with, and if we look at view content, then actual content as PM format and the chain 1, which is a CA bundle. But where is the private key information you can get? So what you can get it is using CLI command. So what I can show you, yeah. There we go. So this is the actual command I executed, OCI CLI command, to get all the information of this certificate with private key. Yeah, I think this is the server certificate I did. So what needs to be provided is just the OCID of certificate with the bundle type option with certificate content with private keys. Then based on the authentication authorization setting, this OCI CLI command will provide all the information about the certificate in OCI certificate services. I mean the specific services with that OCID. So what you see over here, the actual CA bundle, chain certificate in CA certificate in PM format, a little bit modified PM format, because what you see, the new line is replaced with the like backslash and. So then I can get the private key information from here. So this is how you can get. So I think it's a good idea, because private key is supposed to be secure, and then maybe it's not good idea showing from UI. So that's how you can get the private key anyway. So yeah, so that's how I provided the client to, yep. Oh yeah, I haven't done yet. Let's go there. Yeah. So let's just provide client certificate, just name C2. We are expecting 401. Yeah, so C2 CRT key C2. Yep, that's it. And create certificate. I'm expecting the 401 error if I send request. So let's send it. Boom. Yep, 401. Nothing special. So let's check the error log from logging service. There we go. But no. Okay.
And validation failure.
Hey, there we go. So we have different errors, send validation failure. So I think this is how you can do, mutual TLS for OIC API endpoint with API gateway service, OCI certificate service, OCI DNS services, and key management service all together. Yeah, so maybe it's time for close.
So that was a great demo, Jen. So you showed the fact that, a couple of things. You showed one, with authentication without the cert, obviously that fails once you enable mTLS. Then you showed a client with the right cert that succeeded. And then from that demo, you also showed a client that has a different cert that wasn't able to access the API. So let's summarize this session up. So one, what we've really talked about is using mTLS with OIC endpoints. So Jen, why would customers want to do this?
Okay, firstly, I think Stan, you explained from the beginning. So we know OIC is good as a client for mutual TLS, but as a server, it hasn't got that capability yet. So we just want to fill the gap by APIGateway. And by doing that, I think I mentioned already, so like some industry like the finance industry, they have obligation to use this kind of, the security measures. So we know open authentication will give authentication authorization. And then we add one more layer of, the client verification. So whether that client really trusted or not. So for example, if someone, I don't know, maliciously get that token for open authentication, then of course it will go through whole journey and then hit the endpoint and then they can steal something. So we just want to protect them, that kind of step, by putting another layer for client certificate with CA verification. Make sure client is trusted, genuine, and yeah, that's all about. And I think the wireless give another layer. So all three protection layer bundled together means the API client is the real one, not someone is from different wonderland. No, so it is the verified, trusted, and is known to API endpoint. I think that's the whole purpose of this mutual TLS. And it is done from OCI. We haven't leave OCI at all. So you don't need to go for another tooling, etc. So you can do it in one shot.
Yeah, and I think that was a great summary, and really a great summary of the last 3 sessions that we've done around OIC APIs. The fact that we have all of these options at our hands to use to secure them. Yeah, secure access via IP whitelisting or allow listing, control who can access them via mTLS, but also, control authorization through OAuth, as we did in the previous video. That was a great video, Jen. Really, really insightful and amazing to see what we can do around, mutual TLS with the OCI ecosystem when we use it to front an OIC endpoint. Thank you so much for putting that together. Great session.
Thanks, Stan, and you're a nice host for this episode, I found.
Enjoyed it.
Okay. Thanks, Stan. Bye.